you and the brother, right?
Yeah, divided four
So
oranges.
you choose between there's four oranges, right?
Yes.
So I think
I'm just rereading the problem.
okay. So I think how many ways can you put four oranges in piles? Okay, I'm going to do something like 1L, 3R. That means one orange in the left pile and three in the right pile.
Okay.
Okay, and 2L, 2R, meaning this.
Yeah.
And then
Three
3L,
and then one.
1R. Yeah, so it's like 1, 2, 3, and then 1. Okay, then what does brother do?
Um, he decides which of the two piles he wants.
Right.
He keeps the pile and get the other pile. Okay.
Okay, so say your brother moves here, right?
And the fact that it says both, it doesn't matter that you said both of them like oranges because we still have to put out every strategy that they might do. Okay.
Exactly right. You might say, for example, if I do 1L and 3R, why is the brother ever going to choose L, right? Because
Yeah.
that's one. That's he would definitely choose the right one, but
But just to keep in
just to
mind
keep
the
yeah
other strategies.
exactly.
Okay.
Okay,
Got
so
it.
what are brother's strategies here?
He can choose left or he can choose right.
Right. How about here?
Left or right. And left or right.
Okay. All right. So now it's just a matter of payoffs.
Okay.
Okay. What do we write here? So what is your payoff if brother chooses the left?
My payout is good.
Right. Which is
because I like oranges.
yeah exactly. So
Which is
we'll just say call three, right? Because there's
okay.
a number of oranges. How about brother?
0.
Well, he
No,
gets one.
negative 1.
He just gets one. You could, in some ways, it doesn't matter, right?
Okay.
Because right, like we said, all that matters is the order. But we'll just say it's
1.
convenient for
Okay.
oranges. And I'll write down payoffs are you, brother.
And that specifies who's first.
Yeah, I
Okay.
mean, almost usually that
Player
this
1.
player one is the first one, but sometimes it's a little confusing because, for example, say I change the game, say we're putting brother here, then
Then
like
brother will be first in these payouts.
right.
Okay.
But so that's why it's nice to have. If you do this little legend, that's kind of convenient and nice.
Okay.
Okay, so if I do this split, put one in the left and three in the right, and brother chooses the right, then what are the payoffs here?
If the brother chooses right, then he. Oh, it's 1 3.
Right, okay. I get one, he gets three oranges.
Okay.
Okay, if I choose 2L and 2R, two in each pile, if brother chooses the left pile,
Then it's 2 2.
then
0 or 2
yeah,
2.
yeah, exactly. He gets two and I get two. What if he
Okay.
chooses the right pile?
2 2.
Yeah. Okay, if I do three on the left and one on the right, and he chooses left,
He gets
he gets
1.
uh,
If brother chooses left, oh, he gets
yeah,
3.
right, exactly. And I get one.
Mhm.
And if he chooses the right one,
Then you get 3, and he gets 1.
that's it. I think in
Oh.
my answers I do a 0 and 4. You could just kind of see the same thing. I have
Yeah.
shortcuts.
So how we do
Okay.
um oh perfect Nash
Right.
equilibrium.
Something perfect. So yeah, if you were to find all Nash Jacobi, you'd have to do the matrix kind of
The
thing, right?
table. Yeah, okay.
So there would be three strategies for you, and for brother, how many strategies would there be?
2.
Well, there'd be. It's not just left or right. It's remember, it's all possible colorings like left, left, left,
Right.
left, left, right, left. You see what I'm saying?
Oh my
Those would
god.
all be
Can we
different.
model that? We don't have to fill in numbers, but
Oh
just
yeah,
how I
okay.
would set it
I
up.
would look. I would say, okay, so person you would be 1L, 3R. Oops. 2L, 2R,
Mhm.
3L, 1R.
And that's you.
That's me. And then I think it would be something like, I need more space actually. Oof, not too good. One would be left, left, left. This is like left always. And so if I make a legend, this is what the brother does if 1L, 3R.
Mhm.
This is if 2L, 2R. And this is if 3L, 1R. You see what I'm saying?
Yeah.
This is kind of like arrows which all go up like that.
Okay.
Another one would be like left, left, right.
Okay.
That'd be this, this, this. So it'd be like left, left,
Left.
right.
Okay.
What would another one be, for example?
Left, right, left.
Yep.
And that would be left, right, left.
Exactly. Right.
But how does that go back to you?
Well, it doesn't. This is just a specification of what my strategy
Oh,
is.
what your strategy is.
So then, once I write them all down, then I can put the payoffs in, and then we can figure out
Based
what
off
people.
what you would do.
Yeah, exactly right.
Okay.
Yeah, exactly.
Can we fill in one?
Okay, sure. For example, let's do this one. What goes
Okay.
in here?
So if one does left
Right.
and then you do left,
Right.
your payoff is
Exactly.
3 1.
Very good.
If you do do, and then brother does right, then your pay answer is 1-3.
Right. So, but see, one's taking this strategy, and then in this example, in this one, what we're saying is he does left if you did 1L3R, right?
Yes.
So that's why we got 3-1 in here.
Got it.
Okay. How about this one? What goes
If he does 2L, we do left.
Okay. In this strategy, we are saying that brother will tell you right in that case.
Oh,
See?
so we're moving down one.
Right.
Oh,
So
okay.
in this case, we're doing left, right, left. And then if the U did this, then we'll end up here at 2-2.
Got it.
Make sense?
Yes.
Okay, how about this?
So if you do left.
Oh, so this is 3L1R. This is down here.
Oh, 3L1R. Then you do left.
Right.
So you do 1-3.
Right, exactly. So that was what that would look like.
Oh, okay, I got it.
Okay, so but we didn't do this because this is not asked in the questions, but yeah, that's how you do it.
That's how you do it. And then for backward induction to
Okay,
find a subgame.
Okay, so what does brother do here? If we were to get rid of this.
Okay, brother, if you go, his better payout is if he goes right.
Yeah, those threes being the one. Very good. You'd rather have the 3 oranges. Okay, so how about this one?
Oh, so they're separate games.
Yeah, exactly.
Okay.
This is one sub game. This is another sub game.
Okay. So, are we still worrying about brother? Oh, it
Yeah,
doesn't matter.
Yeah, well, here we're just checking what brother's going to do here. Yeah, here it doesn't matter. It's a tie, so you can just choose whatever.
Okay.
Just choose this one. Okay, and finally, what does brother do here?
Brother is if he goes left.
Right, because three's bigger than one. Okay, so now we filled in these. It's good to fill them really. Okay, now we can go backwards and figure out what you will do. If you play down here, there's 3L1R. What ends up happening in the end?
I get 3. No, 1.
1, right? Because you did 3 oranges on one side, 1 on the right, and he picks the 3 oranges. You're stuck with a 1.
Okay, and if you do this, you get 2.
Right.
If you do this one, you get 1.
Right.
So it's better to get 2.
Exactly.
So that's our sub game perfect.
Yeah, this is something perfect. That's what backward action is. That's it.
So our sub game perfect will equal to no, it will equal when you go 2 left, 2 right, and then brother goes right.
Right. That's what
I would write it down.
No, right. That's what you would observe. But the subgame perfect what you'd have to write down to specify the whole subgame perfect national theorem is this whole thing. That is, you have to specify what brother does down here and brother does down here.
Even though we're just doing this.
Yeah, exactly right.
So we would say 2 left, 2 right. Oh my God! And then how would I?
Well, okay. For example, that's why it's key. So that's why if you simply that's what the graph is for in some sense. If you just simply write down the arrows, that's exactly like saying all those if statements, right?
Oh,
so if
I
you
could just
color
say.
The arrows, that's it.
Oh, so I don't have to write them down.
No, necessarily. No.
Okay.
Unless you really want to. It would be something like this one would be RRL or something. Would be one of these things in here.
That's confusing. Yeah, so I'd rather just.
Yeah, exactly. And the key thing again is you have to make sure that you color an arrow from every point. Right? From every node, there must be one arrow colored because you have to specify what everyone does at every node, even the nodes which are not reached.
Okay, got it. And then for the this is Nash equilibrium, correct? So when I get confused when it's a bigger graph, like you know how the smaller graphs we're able just to find based off what 2 does, we can find what 1 does. This one, how will we find just our higher numbers? We just put our pluses in.
Still the same one, yeah.
Okay, so I don't need to do this type of thing. I just look and
yeah, exactly right. Yeah, you would just look among all these 8 numbers and see which is the highest ones.
Got it. All right, thank you.
Is that it? Okay.
That's it. I'm sorry it took so long.
No,
This helped so much.
Okay,
a lot. So hopefully, if I have more, I'll be back.
Okay, cool. Right.
Thank you.
Okay, sure.
And then can I take this one as well?
Sure, yeah.
And I'm Kiara.
Okay,